Welcome, this is James Graves, and it's time to move through another module. In this one, we're going to be talking about IPv4 network ranges, default mask values, and Cedar notations. Up to this point, what do we know? Well, we know how to convert decimal to binary. We got a little cheat sheet up here if we need to make some conversions. We understand our IP class ranges, A's, B's, and C's. We understand those private ranges that exist inside those same. Remember, private internal networks, and the remaining addresses in these ranges are public, or things that communicate on the public network, the internet. Now, whenever we get a class assigned based on the initial bit pattern that we see, devices can quickly associate a default mask value. So what are we talking about here? Well, let's remember that we have a class A. A class A has a beginning bit pattern of 0. Okay? 0 anything. If it starts with a 0 in this bit pattern, the value will be no higher than 127. Alright? If all of these bits are on, we're at 127. If all of these bits are off down to this point, then we're dealing with 1. So class A, 1 through 126 has a beginning bit pattern of 0, and now comes the new piece that we're going to introduce. That means by default, as a device sees this as the initial bit pattern, it understands that it should have a default mask value associated of 255.0.0.0. What in the world are we talking about? Let's break the rest of these down, and then we're going to get into some detail around this concept. What does our class B's begin with? Well, if that first bit is on and that second bit is off, regardless of what happens afterward, we are then dealing with a class B. How do we know? Quick review. If this guy's on, we at least have 128 as the initial value. This guy's off, we know we're going to be no higher than 191, because if these are all on, we're at 191. If they're all off, we're at 128. So that puts us in that range. That means that the device understands that we should have a default mask value of 255.255.0.0. 192 to 223, we are paying attention to the first 3, 1, 1, 0. So regardless of what happens from this point down, if I start 1, 1, 0 as my bit pattern in my very first octet, I'm at least at 192. I can be no higher than 223. So regardless of what happens here down, I know I'm at a class C, and I know I have a default mask value of 255, 255, 255.0. Let's figure out what in the world this mask value is and how that comes into play. Well, as we said earlier, when we see an address, an IPv4 address, we understand that we are dealing with a portion of it locating where a device is located at. In other words, a network portion of an address. There's another portion of that address which will be the actual host. So one piece is going to be location, or the network. Another piece will be device. Our mask, our subnet mask, That's what creates that division for us inside of the IP address. We're going to work with Class C's because Class C's tend to be the easiest to understand. So looking at this right here, Class C, we're going to have an IP address that begins 192.223, a bit pattern that starts here, 110, and a mask value of 255.255.255.0. So let's look at my IP address again. We're dealing with 192.168.1.7. You see that mask value underneath of 255.255.255.0. Okay? So 192.168.1.7. This is our mask. As we're beginning here, it's a lot easier to write this guy underneath the IP address because these octets, they correspond to one another. What is this value right here, 255.255.255.0 in binary? Well, we understand that we have a potential to reach 255 if all bits are enabled, right? So that means that this value becomes this right here. This guy equals 255. This guy equals 255. This guy equals 255. This guy equals 0. So we can now quickly take this mask, look at it here in a binary pattern, and what we actually end up doing when we do that is we are creating our division from our network to our host values. We are saying at this point, these guys, anything associated in this last octet becomes our host portion, and anything associated this way, this becomes our network portion. This is our location. This is if we need to send data to that device, where do we send it to? This is the device or the host that we're communicating with at that point in time. When these ones stop, the network portion stops. When the zeros start, our host portion begins of our IP address. So if we correlate this octet to this octet to this octet, this portion right here, that is my computer. This portion right here this is where I am. We have a network portion and we have me on that network, and it is created by that division and that mask. Now here's something very interesting. Let's take a look at these, at how subnet masks can be created and established. Get all this out the way. Now we understand that if we want to create the IP address of 192 for that octet, on, off, 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 right? We wanted to make 168. Well, we're going to go on, off, 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 right? So you see how we can kind of slide bits in and out in this pattern to create a number? Subnet masks do not work that way. Subnet masks have to create that division based on where the ones are and where the zeros are. So subnet masks have to build this way, left to right. If we look at our default mask of 255, 255, 255, 0, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, then zeros. We cannot just put a 0 somewhere here in the middle. It cannot be 1, 1, 1, 1, 1, 1, 1, 0, 1, 1, 1, 1, 1, 1. Wouldn't happen, because then where's our division? Our division then gets messed up. Subnet masks build from left to right, and the bit to the right cannot be enabled if the bit to the left is not enabled. There's our division. So now we understand that we have this guy. One 92, 168, 1, 7. Network, network, network host based on the corresponding values of our subnet mask. Look at all those zeros. Here's something else interesting. Now remember, an IP address, not the mask, the IP address, this guy can be anything from 0 through 255. Well, this mask that's directly associated tells us what this range can actually be for this particular network that we may be referencing. As an example, if we have a mask value of 255, 255, 255, 0, corresponding back to my IP address of 192, 168, 1, 7. Understanding that this octet, let's get another color in here, understanding this octet right here can have a value anywhere in this range, 256 potential numeric values up here. We take our mask, and if we subtract what our mask value is to that octet, just this octet right here, we will see that we have locked it to one address only. This network can only have 192 in that octet. Take this second block here, we're going to create that same division, 256 possible numeric values up here, minus the mask value associated to that octet. We can only have one possible value for this network in that octet. Repeat the process here. We can only have one possible value in that octet. Network, network, network. My city, my street, my state, my zip code, that is not adjusting in this example at all. That is where we are. But this guy right here, how many people reside at that residence, can adjust. So we started off with 256 potential values up here. Our mask is indicating that we're going to limit that range by 0. So we can have 256 potential values up here, or this full range for that IP of 0 through 255. Now that helps us out because we have to determine these ranges, because we have to understand two different things. We have to know, one, what is the network ID? In other words, what is the identifying address for that network? And we also have to understand, what is our broadcast for that network? In other words, if we have to communicate with every device on that network, where do we send communications? What address can we send it to so that it gets replicated and, so that it gets communicated for every device to receive it? Remember, if you want data sent to me, you send it there and I get it. broadcast means if you want communication sent to me and the printer and the server or another device or any other devices that exist on that network, what is that broadcast address? So that it's like we take out a megaphone and we scream into it so that everything in reach can actually hear the same communications. Well, that's going to be our broadcast. Once we determine those, we can now determine what the range is that we can actually assign to devices inside the network, because this cannot be used for a host. This cannot be used for a host. Wouldn't make sense if I had an address that was the broadcast, so when you send communications to me, it went to everybody. You cannot assign this to a device. You cannot assign this to a device. But we will have to determine what our ranges are that we can assign devices to. So here's what we're talking about. And this guy right here, we know for this network, we are limited to this. We know that this is the very first possible value that could be in this host range, because we're dealing with anything from 0 through 255. So that's the very first possible number. That identifies our network. What is the very last possible address that we can have inside this network? 255. That is it. That maxes it out. That's our 256 potential values right there. That is the broadcast. Now, what do we assign to any of our devices? Well, DHCP or static, however we're associating addresses to devices, they would have to be specified in this network in this range. Anything from 192.168.1.1 to 192.168.1.254, anything in that range is what I can put to a PC, to a device, a phone that may be attaching to my network, to a printer, to a server. But recall that we have to understand this, because we cannot have duplicate IP addresses on a network. Therefore, that's where our ranges come into play. If I needed enough addresses to communicate to 300 devices on this network, I could not use a Class C based address with a mask value like this, because I'm limited. I'm limited to 254 possible values. If you took this mask value, subtracted from the octet, you understand that there's 256 addresses in that network. Subtract the 2 that you cannot use, you will then be able to determine your usable range. 254. I can have 254 devices that could exist on this network. Now our Class B addresses, we're going to understand first off from our previous modules that we're dealing with 128 to 191. So again, quick review. On, off. This means we are at least at 128. We're at a max of 191, because if this bit is not enabled, we can't reach 192. Okay, so on, off. And we're now dealing with an IP address that begins that first octet 128 through 191. Our default mask value 255.255.255. Oh, too far. Doing a C. 255.0.0 or 1 2 3 4 5 6 7 8. 1 2 3 4 5 6 7 8. And then the rest of our bits are off. So what are we saying here? Well, let's put an address down here. Let's get it in that right range and let's take a look at it. We're saying, let's see, 128 to 191. Let's put us at 142. 21, 167. Let's back that up. I'll tell you what, let me extend this guy out a little bit so we can fit it in here. 167.22. That'll work. Looking at that and judging from our mask here, we are saying at this division point, this guy defines our network, and this guy defines our hosts inside the network. So you can see that division taking place right there. So in other words, our network address, remember we need to find our net ID 142.21.0.0. That is the first possible network that could exist. Network. These can be anything from 0 through 255 and 0 through 255. Our host address in this example is the 167.2. That would be the John Doe or the Jane Doe, or in this case the computer, the device, the server, the printer, whatever it is. That is his identifiable address. This is how you find them. This is our network. So we go network, host. Recall that these octets, anything from 0 through 255, so this first block here can have 256 potential combinations or numbers in it, and this guy can have 256 potential numbers in it. When you multiply those by each other, you will find that our networks can have 65,536 unique addresses in there. The unique addresses are everything from 142.21.0.0 to 01.02.03. This guy continues to build until he reaches 255, and then the next one becomes 1.0, 1.1, 1.2, and this continues to build until we hit 255 again. Then this third octet here actually becomes 2.0, 2.1, 2.2, and they continue to build that way. So when you go through that whole cycle, and this guy builds all the way up to 255, 255, we're looking at 65,536 addresses. Of that, 2 of them are not usable. Do you recall which 2 are not usable? What you should be thinking to yourself is, my net ID is not usable? And which would be this guy right there, 142.21.0.0. That's the first possible address. Your broadcast is not going to be usable, which is 142.21. Remember, those do not change. Those are our networks. That's our network address. This is where we have some play and some flexibility. There is our broadcast. Not assignable. Alright, these cannot go to devices, meaning that we can assign to a device anything in this range. Whoops. So as you can see, if we are using just default masks, and we have over 254 hosts to put into a network, from a default standpoint, we have to move back up here to a B. Okay? To move to a B, that means that we now have, let's say we needed 350 addresses. We move to a B. Well, a B allows us 65,534 devices on it. That is much greater than 350. In fact, it's so much larger that we would then be extremely wasteful of our addresses. That's why our next nugget we get into here, our next module, is going to be based around creating custom subnet masks so that we can shrink these networks to different sizes. Before we get to that concept, let's do one last example. We're going to look at a Class A and see how that breaks down. Like magic, everything's cleaned up. We have a Class A address here that we're going to look at. Class A addresses are network, host, host, host. Or in other words, they have mask values of 255, 0, 0, 0 by default, which we understand to be 1, 2, 3, 4, 5, 6, 7, 8 bits on, 1, 2, 3, 4, 5, 6, 7, 8 bits off. That in a binary format is our mask value. Now let's get an IP address. Well, real quick, just to review here, if this first bit right here is off, we know we're dealing with a Class A because we know that we'll never reach 128 in value. It's always going to be less than 128, so we're in a Class A. All right. So our number here that we're going to work with, 1 through 126, let's give it a, we'll do 96. We'll say 96, 126, 12, 187. Looking at this number right here, we have a division that's taken place because of our mask. This guy right here is locked into one value, so we are on the 96 network with the lowest possible address being 96,000, and that being our net ID. We're going to have a broadcast now that we can look at of 96. Now remember, 0 through 255, 255, 255, 255. That's our max value. You recall, unassignable. So we are dealing with a range of 96, 0, 0, 1 all the way through 96, 255, 255, 254, which means that we can have how many hosts in this network? Well, let's do the math and figure out what we're looking at. This octet, we're saying we can have 256 here. We're saying we can use 256 here. We're saying we can use 256 here, which is going to mean 250, let's clear that out, 256 times 256 times, there's our 65,536, if you remember that from our Class B. Well, now we got a whole nother octet to work with. 16,777,216 hosts that we can have in this network. That's extremely large. When would we ever need that? Well, we probably won't, but an ISP might have a Class A address, as we saw from the previous nugget dealing with IPv4 classes, public-private. Mine was in a Class A, which means that that was the range. Now that's before they chop it up and make smaller masks out of it. But that is the total possible unique addresses. The total possible hosts, So you got to take 2 out of there because our net ID and our broadcast are not assignable. We can have that many possible hosts. That is a lot of hosts to put into a network. So we have seen at this point in time how to take a mask, how to take a range, determine a class, from a class determine how many hosts can be available in there, identify a network ID, identify a broadcast, and identify a range. These are all very powerful tools that we're going to need to use as we do subnetting coming up. Alright, so the last thing that we're going to cover here in these nuggets, this particular module, will be Cedar Notation. So what is Cedar Notation? It is basically shorthand for the mask. Okay, so what you do is you think bits. Okay, you think of the network portion as opposed to the host portion. Remember, the network portion is anywhere ones exist in the mask. That's how many bits are enabled when you get to Cedar. So let's look at an example here. We have, according to our example up top, we're going to go 192, 168. We got 1, 0. Okay. We know we're dealing with a IP address there. Let's duplicate this guy here. And let's drag him down here. Look at that. Try to get creative and I created a mess. Let's grab this portion here, put that guy there, take this guy and put this guy here. Okay, let's group all those and slide them over like this. Now here we go. Let's look at this guy. Come on, you gotta be kidding me. Alright, let's get back over here to this. Let's adjust our values. Alright, we're going 255. You guys should know this. Alright, you got to know this. We know we're dealing with a Class C, so we have to understand we're dealing with 255, 255, 255, 0. In other words, we're dealing with a network portion, a network portion, a network portion. They do not adjust a host portion. Okay, this Cedar notation right here, 1 2 3 4 5 6 7 8, 1 2 3 4 5 6 7 8, 1 2 3 4 5 6 7 8, 1 2 3 4 5 6 7 8. How many bits are enabled? Remember, these are bytes of information, so they're 8 bits per octet. 8, 16, 24. 8 bits here, 8 bits here, 8 bits here. So we're dealing with a Cedar notation of 24/24, just like we have up here. Okay, let's look at this little diagram I created. This should help you out. Stretch it all the way across. Alright, so what is Cedar notation? Shorthand mask. Think bits. So the IP address 192.168.10/24 references these bits right here. Let's go back. Let's get this guy out the way. Let's get this guy out the way. Let's get this guy out the way. Let's erase this. There we go. So what we're dealing with is this address of 192.168.10. 255. Look at this. 8 bits on. Match the green to the green. Red 255 to red. 8 bits on. Orange 255. Orange 8 bits on. Last octet is 0, our host portion. There you go. So Slash 24 basically means the first 24 bits of the mask are enabled. What happened if this happened to be a class B? Remember our class B default masks. Class B default masks. Let's grab this blue, it'll show up pretty well. Class B default masks are 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. What does that equal? Slash 16. The first 16 bits are on. So 255, 255, 0, 0 is a slash 16 Cedar notation. Okay? Class A, we basically just jump back up here. 1, 2, 3, 4, 5, 6, 7, 8. We are then dealing with 0, 0, 0. How many bits are on? The first 8 bits are on. That's all Cedar is. Very quick and simple. If you see a slash and a number, that tells you how many bits are enabled. Now remember, mask values only build left to right. This is, again, this is not an IP address where we create the pattern we need to get the number we need. Does not work like that. Mask values build from left to right. Okay? So this 9th bit right here cannot be on unless this 8th bit right here is on. You cannot get to a slash 16 until the first 15 before it are enabled. Same for a C. Let's look at 172, 31, 28, 40. What are we looking at here? Well, we understand that we're dealing with this as our first 2 bits in our binary for this octet. So we are in a class B. We understand that with a class B, we're dealing with a mask value that is network, network, host, host. We also now understand that we are dealing with a default value of slash 16, 8, 16. The first 16 bits are enabled of our mask. At this point in time, we should be very comfortable doing decimal to binary conversions. We should be very comfortable understanding our classes as well as our private ranges. We're going to have to remember those as well. We should be very comfortable understanding IPv4 network ranges. If we get a default mask value, a slash 24, a slash 16, or a slash 8, we should be able to associate that back to a class, and we should be able to understand from a default mask value our network portion and our host portion. We should understand where the network ID is, where the broadcast is, what the network range is, and we should also understand our Cedar notation. If we get a slash whatever, we should understand what that means. Slash 24 means the first 24 bits are on. We have to understand those concepts, because from here we're going to begin moving into subnet masking now, where we create custom subnet masks and we increase and decrease network sizes based on that information that we're going to provide in our mask bit. Okay? This is James Graves. I hope you had a good time going through this module here, and I'll see you with our next video. Thanks.